Let's now talk about conditional probability. Conditional probability is always about when I say given a probability B, given an event B, happening, find the probability that A happens as well. So now, what does this mean? I start by the given. Since given an event B is happening, I only look at event B. I don't care about any other events inside my Venn diagram or in my sample. So the new sample space I'm dividing by is simply event B. So I always, in this case, I divide by the probability of B. Now I have to look only at circle B. Because it is given B is happening, I only look at the probability of B. In this probability of B, I want to find out that probability A happens as well. So, in this probability of B, where is the probability of A happening as well? It is this area. The intersection between A and B. So I have the probability of A intersecting B. This is called the conditional probability. I always look at a new sample space, and from that new sample space, I found out whatever probability I want to find. So the formula is B could be written as the probability of A given B is always equal to the probability of A intersection B over the probability of B. So always after the given, this goes down into the new sample space. I consider the probability of B is to be the new sample space. So I only look at this new sample space and I take out whatever probability is based on this sample space. Let's see an example to show the conditional probability more clearly. In a classroom, there are 30 students. 15 can speak Spanish, 10 can speak German, and 5 students can speak both subjects. A student was chosen at random, given he speaks Spanish, find out the probability that he speaks German as well. Since I started my question by given or F, then this is a conditional probability. As always, I start solving a similar question by drawing a Venn diagram. So I have to draw a Venn diagram first. This is my diagram. And I have to draw my sets inside. This is my universal set, and I have speaking Spanish, this is S, and I have speaking German, this is G. I always start filling from the most intersected area, so who speak both languages are 5. Now, who speak Spanish are 15, so this would be 15 minus 5, which is equal to 10. This area, and who speaks German only, who will be All of students speaking German are 10, so this area would be 10 minus 5, which is equal to 5. So now, for my question, I want, given he speaks Spanish, so my new sample space would be speaks Spanish. So I look at the students who speak Spanish. So my probability would be equal to having a new sample space, which is the student who speaks Spanish, which is 10 plus 5. And from the students who speak Spanish, we want to find out the probability that he speaks German as well. Where is the intersection between the German language and the Spanish language? Here is the intersection. Here is the intersection, so I have 5 students. So ending up having my probability to be equal 5 over 15. I hope it's clear. Always when I want to find conditional probability, I form a new sample space, and from that new sample space, I find the value I want and I divide it on the new sample space.